So hi everyone, I'm Pramanshu and today I want to talk about Bayes' theorem. So Bayes' theorem is based on conditional probability. So we'll be using it to solve conditional probability type of questions. For examples, the questions where we would apply Bayes' theorem would be asking something like, what is the probability of event A occurring given that event B has already occurred? So in these type of questions, we'll be applying Bayes' theorem. So let's derive this theorem, like what is the formula? So we'll be using conditional probability equations to derive this theorem. So we know that probability of event A occurring given that event B has occurred is equals to probability A intersection B divided by probability of B. And we can also say that probability of event B occurring given that A has occurred is equal to probability of B intersection A divided by probability of A. Now, if we look in these two equations, we can see that probability A intersection B is equal to probability B intersection A. So what I'm going to do is I'm going to substitute this value in this equation over here, right? So let's do that. So we get probability A given B is equals to probability B given A multiplied by probability of A divided by probability of B. This is what we get, and this is what Bayes' theorem is. So now, if we flip the events, we can say that probability B given A is equals to probability A given B into probability of B divided by probability of A. So now this is the theorem, this is what we have, and this is what we are going to apply in our questions. I believe in minimal theory and maximum application. So now we focus on the application part because this is all the theory that we need to solve our questions, right? Now the questions can get tricky, but just remember that this is the theory that we need. This is Bayes' theorem. That's it. Now I have a question for you. So let's go through it. So it says that we have a rare medical disease and we want to find out the probability that the person has the disease given that they tested positive. Okay. Now there are cases of false positives also, like the test, uh, like the person does not have the disease, but they get tested positive. As we all know, like if you have COVID, it's not necessary that you might get tested positive. And it's also possible that if you don't have COVID, you can get tested positive. So there are cases of false negatives and false positives in medical science. So so now let's go through the data that we have. So it says that probability of the disease is 0.01. That means like 1% of the population has this disease. Okay. Forgive me for my handwriting. It's very bad. And then we have probability that a person gets tested positive given that they have the disease is 0.95. That means 95%. That means The person has the disease and they are getting tested positive is 95%. So the probability that the person gets tested positive, given that they know they don't have any disease, is 10%. So the person does not have the disease and they might get tested positive. So the probability for that is 10%. We need to find out that the person has been tested positive. What is the probability that they actually have the disease, right? So now let's think about, like, this is conditional probability. So can we apply Bayes' theorem over here? So let's first write down what the Bayes' theorem says. So it says that probability of disease given that the person tested positive is equal to probability of being tested positive given that the person has the disease multiplied by probability of disease divided by probability of getting tested positive. Now, if we look at it, then I can see that, do I have this value with me? So I can see that yes, I have this value with me. And then if I see probability of disease, this value is also here. So we need to focus on getting this value. We don't have this value, right? So we have to find this value. So how do we find this value? Let's say probability of testing positive can occur in two cases, like probability that you get tested positive given that you have the disease multiplied by the probability of disease, because yes, you have the disease and then you get tested positive for it, right? Or we can say that probability that you don't have the disease and you still get tested positive for it, right? So now, if we put in the values over here, that what is the probability of getting tested positive given that you have the disease? It's 0.95, right? We have this value 0.95, which gets multiplied by probability of disease, which is 0.01. And then what is the probability of no disease? It's just that 1 minus probability of disease, right? So it's 0.99, okay? And then do we have this value? Probability of testing positive given that you have no disease is 10%, right? So we write that over here, 0.1, right? Now if we solve this, what we get is 95 into 10 raised to power minus 4 plus 99, or like 9 point, or like 990 into 10 raised to power minus 4, okay? So now adding this up, I get this 1085 into 10 raised to power minus 4, which is just 0.1085. So yeah, this is the probability of testing positive, right? Now, I have to substitute this. I have to substitute this in this equation right over there, right? So now let's find out the solution. Okay, so probability of having a disease given that the person gets tested positive is equals to 0.95 multiplied by 0.01 divided by 1085 into 10 raised to power minus 4. Yeah, and if we solve this equation, we get our answer. So always remember that Bayes' theorem is applied in questions dealing with conditional probability, where we already have the probability, where we already mentioned that event B has occurred. Now tell me what is the probability of event A occurring. So it's like they give you conditions, and then you should think in the direction of using Bayes' theorem, right? And also, what we used over here is the law of total probability, right? So if you don't know about it, you should look that up. But it's very intuitive. The law of total probability is intuitive. So yeah, you can look that up if you don't know about that. And yeah, cheers guys.